Hey everybody, welcome back to the Dabbler's Den. I'm Chris Cottrell, and today I want to discuss the probable relationship between the Carolina Bays and the Michigan Basin, which includes Saginaw Bay. If you've been following along with my series from the very beginning, you've probably seen me use this image right here on more than one occasion, but I really haven't taken the time to explain it, especially this part right here. Well, that's what I want to do today, and I want to go ahead and start with some very basic geology. The first thing I want to discuss is the basic principle of original horizontality. This principle or law states that sediments are generally deposited into horizontal layers or beds due to gravity. Sediments are washed down rivers and get deposited in flat layers. These layers build up and can later turn into sedimentary rocks. Another basic geologic law is the principle of superposition, which states that because of this horizontal stacking of sediments, the oldest rock layers are going to be at the bottom and the youngest layers are going to be on the top. And now all of this is simple enough and often used by geologists as a relative dating technique. And you can see a few examples there on the bottom. For instance, the Grand Canyon has those horizontal layers of sedimentary rocks. Now, after the sediments are turned into stone, these layers can be subjected to tectonic activity that may lead to faulting or folding. If the rock layers get folded upwards, they can form into what's known as an anticline. And if the layers get folded downwards, they become a syncline. And one of the ways that I've always remembered this is that if you could draw a horizontal line across the fold and it looks like the capital letter A, then it's an anticline. Now, sometimes the entire area can get pushed up by tectonic processes deep within the earth, perhaps a magma chamber or something like that. When this happens, a dome can form. Now, if the top of the dome is exposed to the erosive processes at the surface, it kind of wipes away the top, and a ring structure can form with the oldest rocks being in the middle, and then they get younger as you move out towards the edge. The Rycat structure in northern Africa is a great example of a dome, as is Upheaval Dome in Utah. Now, again, these dome structures were created by processes pushing up from beneath them, and then erosion exposes the rings of the bedrock. Now, if the area gets pushed down, a basin forms. And again, if the top layers are removed by erosion, then in this case, the youngest layers are found in the middle of the ring structure with older rocks as you move out. There are a few examples of these around the world. For instance, the Paris Basin is a good example, but none that I can find are more pronounced with that ringed feature than the Michigan Basin. Okay, so here's a closer look at the Michigan Basin, and you can clearly see that it is a basin, with the youngest Jurassic rocks in the middle, going out to Devonian age rocks on the outer edges. So Jurassic all the way out to Devonian out here on the outer edges of that basin. Keep in mind that all of these rings were originally flat horizontal layers. So what can cause such a large area of land to be pushed down for a basin like this to be formed? Well, the weight of ice can do it. However, as you can see here, there were during our last ice age, and more than likely previous ice age advancements as well, much thicker layers of ice, over the Laurentide ice sheet, much thicker than the southern portion of Michigan here. So why aren't those areas depressed and pushed down in basins as well? And speaking of the Laurentide ice sheet, one of the big questions of this debate has been whether or not the Saginaw Bay area was even covered by ice at the onset of the Younger Dryas. Antonio Zamora just put out a great video on this topic, and you can see it by clicking the link above. And he basically shows that there is confusion, first of all. And I think one of the reasons why we see confusion here is because we literally have ice here one day and gone the next, which has led to quite a bit of confusion about this area. But he shows that, yes, indeed, there is literature out there that shows that this area, in fact, had ice on it at the onset of the Younger Dryas. So click that link above and check out his work. But anyways, what else can cause the original horizontal layers of the Michigan area to be pushed down, forming a basin? Well, how about a cosmic impact? um, you know, is this something that would be unheard of? A cosmic impact causing horizontal layers of bedrock to be pushed down to form a basin. Well, as a matter of fact, no. While researching basins, I came across the Sunbury Basin, which is not far from Michigan. It's just on the other side of Lake Huron. And this basin is, while it's much older, at over 1.85 billion years old, it has been confirmed to have been created by a 10 to 15 kilometer wide meteorite, or more specifically, a bolide impact. Um, suspected to be much more ring shaped when it was created, and then over time, a couple billion years, it kind of stretched out a little bit. The basin does clearly show similarities to the Michigan Basin. Again, with the youngest rocks, which aren't very young in this case, but then as they move out, they become older and older. So yeah, this is definitely, not too far away. This is definitely a basin that was created by an impact. So this is not unheard of. So to wrap this up and to summarize what I think happened, again, I believe that we had a fragment of a comet, among others, that entered the Earth's atmosphere and struck the Laurentide ice sheet directly above the center or focus of the Michigan Basin. The crater that would have been formed was most likely in the ice, obviously, and the upper portions of the crust just above the Jurassic layer. The shock of the impact caused the sedimentary rock layers down, forming the basin. I do believe that what was left of the comet fragment did create Saginaw Bay, and its final resting place before massive flooding was at the deepest part of Lake Huron. The objective of this impact threw tremendous amounts of ice that came crashing back down everywhere within 900-mile radius of Saginaw Bay in the Michigan Basin. If the ice came down onto unconsolidated ground, liquefied by the initial impact's shockwave, they formed secondary elliptical depressions, the Carolina Bays along the East Coast and the Nebraska rainwater basins of the Midwest. Immediately following the impact onto the ice sheet, the steam and ice released into the upper atmosphere would have greatly increased the Earth's albedo, causing a so-called nuclear winter and sending us back into the ice age for another 1,200 years. The amount of glacial floodwater would have been unimaginable and would have completely wiped out any evidence of the crater itself, other than the bedrock geology underneath it. The evidence of the flooding can be seen all over North America, the North American continent today. Now, this is just my 2 cents, obviously, but I do not believe that the shape of the Carolina Bays and the Nebraska rainwater basins are a coincidence. I do not believe that their orientation is a coincidence. I do not believe that the magnetic anomaly of Saginaw Bay is a coincidence, and I don't believe that the location of the Michigan Basin is a coincidence. There's way more to this story that needs to be told, and we're just now starting to tell it. So anyways, guys, thanks for watching. Help spread the word, and we'll catch you next time. Bye.